The project LEGO meets RV examines how runtime verification can be used to verify distributed systems. We use this assembly line as an example of a distributed system. It is programmed using LEGO Mindstorms robots to move a workpiece, this white LEGO stone, from the bottom right to the upper left. Using distributed runtime verification, one can check whether the assembly line does its job correctly. The new idea is that the check is not performed by one central, but many decentralized monitors on the different agents. In the first example, we want to verify that two workpieces are never simultaneously in the assembly line. This property is expressed as a detailed formula, and this formula is transformed into many monitors for the various agents. In the formula, the annotations denote which subformula is evaluated on which agent. The red arrow shows this relation. Again, we put the workpiece at the beginning and we see. The initial output is a question mark because we do not know yet if the property is fulfilled or violated. Every time the workpiece is in front of a remote monitor sensor, the monitor's formula is fulfilled as long as the workpiece stays in front of its sensor. We can see this once again in the rear sensor of the output conveyor. The workpiece is moved towards the sensor, and as long as it stays in front of the sensor, this formula is fulfilled for a short time and the monitor output is stopped. We now want to violate the main formula. To do so, once more put the workpiece at the beginning. And again, the initial output is a question mark. After the workpiece was moved onto the revolving table, we take it out and put it in front of the first sensor. The output of the main formula's monitor is now bottom, because the workpiece has never been on the output conveyor in the first run. As a second example, we want to verify that there is no workpiece behind the revolving table until there has been one in front of it. Thus, no workpiece appears on the revolving table. In contrast to the previous property, this formula can be fulfilled as well as violated. We concentrate on this area because the interesting part is going to happen in the area of the revolving table. Again, a workpiece is moved onto the scene, and as soon as it reaches the sensor in front of the revolving table, the display in the upper right changes to top because the property is fulfilled. The output does not change anymore with the workpiece moving on, because the formula cannot be violated anymore but is fulfilled once and for all. In the second run, we violate this formula too. In order to do this, we put the workpiece directly in front of the sensor behind the revolving table rather than going through it. In this run, the workpiece has never been ahead of the revolving table but rather after it. Thus, the monitor notices the property is violated. The project LEGO Meets RV has been implemented by Torben, Scheffel and Malte Schmitz at the Institute of Software Engineering and Programming Languages at the University of Lübeck.